Balancing chemical equations is more an exercise in conservation of mass, as opposed to anything actually useful. For example, if I have methane in the gas phase and I react it with 2 oxygen in the gas phase, the products are carbon dioxide and 2 water molecules. This here is a balanced equation already. This is not an unbalanced equation. No one in the real world is going to hand me an unbalanced equation. Again, this is more of an exercise in the idea that mass is conserved in a chemical reaction. All that is happening in a chemical reaction is that I have a group of molecules and they are rearranging themselves, but still the same elements that made up those different molecules are the same. They may be rearranged, but they are all still present. And balancing chemical equations is mainly just that, making sure that equal amounts of product and reactants are on both sides. Here I have 1 carbon, I have 4 hydrogens, and I have O2, so this would be 4 oxygen molecules. So in order for this to be a legitimate reaction, mass must be conserved. If I have 1 carbon, 4 hydrogens, and 4 oxygens on this side, I had better have 1 carbon, 4 hydrogens, and 4 oxygens on this side. And here I have 1 carbon, I have 2 oxygens here, and then I have 2 H2Os, which gives 2 more oxygens. So 2 oxygen, 2 oxygen, which gives a grand total of 4 oxygen. And then there are H2 times 2. 4 hydrogens. So when I add all of these up, I get equal amounts. So this is a balanced equation. If I have something that is an unbalanced equation, for instance, if I react ethanol, which is C2H5OH, with oxygen, and this is in the gas phase, so if I burn ethanol in oxygen, and I am said to get the products CO2, carbon dioxide in the gas phase, plus water, also in the gas phase. This is the reaction I'm given. It is not a balanced equation, and the way I can check to see if it is balanced or not is again by tallying up the molecules. Here there are 2 carbons, 6 hydrogens, and 1 oxygen. And here there are 2 oxygens. So this is a grand total of 2 carbons, 6 hydrogens, and 3 oxygens. Now on this side I have 1 carbon, 2 oxygens, 2 hydrogens, and 1 oxygen, for a total of 1 carbon, 2 hydrogens, and 3 oxygens. And here I can clearly see that mass has not been conserved. There is less mass on the product side than there is on the reactant side. So clearly this is not a balanced equation. So what I have to do is inspect the equation and then try to make it balance out. And usually the best way to approach this is to do it in steps. Find the element first that there is least of, which is carbon. Multiply both sides of the equation so that they are equal, and then go on to the next element, to the next element. It is helpful to start with something that has a smaller amount, like carbon, because here I can easily manipulate the oxygens on this side because there's just an O2 term on this side. So it would be very easy for me to get the right amount of oxygens. However, it will be more difficult for me to get the right amount of carbons because there's only one term for me to manipulate on either side of the equation. And same thing with the hydrogens. It's much easier for me to change the hydrogens because I have the hydrogen on this side, just a hydrogen and oxygen term. And these sort of chemical equations are very, if someone has never done them before, they are very difficult to do. But through time and experience, they become very easy. And to be honest, after a general chemistry class, I'm never going to see these again because, quite honestly, they're just completely useless. If someone were to hand one of these to me, I would just laugh. Any chemist would look at them like they're crazy. So anyways, what I'm going to do is start balancing these equations. I'm going to start with carbon because that's going to be the hardest one to make sure it's equal, because if I start multiplying different terms to try to get them to balance out, I might run into a problem where I have one that it's hard to balance out the other side. Really what these just take are experience. It's really just intuition. After I've done a bunch of these, it became very easy. But anyways, so the first thing I'm going to do is try to get 2 carbons on the right side. And what I'm going to do is multiply CO2 by 2. CO2. So now I have the proper amount of carbons on both sides. And now I've multiplied this oxygen by 2 as well. So I will have a grand total of 5 oxygens. Now, so this side still remains the same. 2 carbons, 6 hydrogens, 3 oxygens. This side I now have 2 carbons, 5 oxygens, and 2 hydrogens. So the next thing I'm probably going to want to do is get the hydrogens to be equal. And I can do that by multiplying this term by 3. Then I'll have 6 total hydrogens. So I'll do that next. Now I have a total of 2 carbons, 6 hydrogens, 3 oxygens on this side, 2 carbons, 6 hydrogens, and now I have 3 more oxygens over here, or an additional 2 compared to the previous one, so I'll have 7 oxygens total. And now the last thing I need to do is balance out the oxygens. The products have more oxygen than the reactants, but there is an easy way for me to fix this. Here I have an O2 by itself, so I can fix this quite easily by multiplying 3. That way I'll have 6 oxygens here and then 1 oxygen here, which will be a total of 7. and this is the balanced equation.